Will the world's most powerful telescope, already in orbit, provide new instruments to answer the age-old question of whether or not humans are alone in the cosmos? According to the U.S. Space Agency, it will look back in time to witness the very earliest galaxies that formed in the early universe. As if those statements weren't daring enough, scientists have now speculated that the future successor to the world-famous and cherished Hubble Space Telescope may have even another exceptional gift, thanks to its 6.5-meter golden mirror and highly sensitive cameras. Although not launched specifically to search for alien life, astronomers cannot predict the unexpected findings. For instance, when the Hubble Space Telescope was launched in 1990, dark energy was absolutely unknown. It is now one of the most fascinating fields of astronomy. What will the Webb telescope learn? Could what the Webb telescope discovers revolutionize our understanding of the universe in the same manner that the Hubble Space Telescope did decades ago? Keep watching to find out. The matter of alien life has always been a puzzle, a question that has constantly been on the minds of all mankind, and the James Webb Space Telescope, or JWST, may be able to identify signals of alien life by determining whether the atmospheres of planets circling nearby stars are being altered by such life. Despite this possibly huge accomplishment, the project was nearly saved from being canceled by the U.S. government in 2011. That was due in large part to its enormous cost, an estimated $10 billion instead of the $1 billion originally anticipated. Back on Earth, astronomers, notably the University of Washington team that proposed deploying the telescope for life detection investigations, are ecstatic at the prospect of its launch. Space telescopes were first proposed in 1923. The most popular telescope is the Hubble telescope, which was funded and developed in the 1970s by NASA, with help from the European Space Agency. In 1990, the Hubble Space Telescope was launched into low Earth orbit and is still in use today. It was not the first space telescope, but it is one of the largest and most adaptable, with a reputation for being both a scientific tool and a public relations boon for astronomy. The James Webb Telescope, which was just launched in December 2021, is often regarded as Hubble's replacement. NASA's largest and most powerful space research telescope is the James Webb Space Telescope, JWST or Webb. With a massive infrared telescope, it is a world-class observatory. Hubble's discoveries influenced Webb's scientific ambitions. The most notable distinctions between these two expensive space-seeing glasses are their distance from Earth and the mode in which they explore the universe. The Hubble Space Telescope is in a fairly close orbit around the Earth, while the Webb telescope will be 1.5 million kilometers from it. Second, the Webb telescope will primarily investigate the universe in the infrared, whereas Hubble will mostly study it in the optical and ultraviolet wavelengths, though it will have some infrared capacity. Hubble's discoveries pushed us to examine at longer wavelengths than Hubble had previously explored. Dust cocoons envelop stars and planets in their early phases of creation, absorbing visible light. With its infrared light, the telescope can peer through these atmospheres to discover what's inside the gaseous shrouds and how they've changed through time. Once the observatory's giant golden eye opens, the telescope's incredible sensitivity will allow it to identify the faint, distant fingerprints of the universe's first stars and galaxies. Webb will look into every step of our universe's growth, from the first vivid glows after the Big Bang through the emergence of solar systems capable of supporting life on planets like Earth, as well as our own solar system's evolution. On December 25, 2021, Webb was launched from Europe's spaceport in French Guiana, on the northeastern coast of South America, aboard an Ariane 5 rocket. The European Space Agency delivered the Ariane 5. The possibility of remotely recognizing biosignatures has become a hot topic in recent years. With the launch of JWST, humanity may be on the verge of achieving a major milestone in SETI, or Search for Extraterrestrial Intelligence. We've reached a tipping point where we can identify not only powerful, purposeful, transitory, and highly directional broadcasts like our own, but also consistent, passive techno-signals with similar strength. Despite the fact that no one could have predicted using the telescope for this purpose when it was created, Webb's infrared sensitivity will allow it to directly observe extraterrestrial worlds. When JWST was conceived in 1989, no planets orbiting other stars had been identified. Exoplanets were first identified in 1992, despite the fact that planet formation theories predicted their existence. According to NASA's Kepler Space Observatory, exoplanet seekers have just lately discovered that worlds orbiting other stars in the Milky Way are as plentiful as grains of sand on Earth. As a result, the Webb team has a once-in-a-lifetime opportunity to delve into some of the most fascinating worlds. According to remote sensing experts, plant life, which obtains energy through photosynthesis, could be spotted in infrared wavelengths, since chlorophyll absorbs visible light but shines brilliantly in infrared, giving planets with foliage a distinct red edge. A single pixel photo of a distant planet might just contain enough information to tell us if biological life exists there, based on the information encoded in the wavelengths of light that reach the telescope lens. Methane may be the first human detection of life beyond Earth, but scientists must proceed with caution before declaring a discovery based on the chemical. Otherwise, one of two things could happen. One could misinterpret something as a biosignature and receive a false positive, or we could miss something that is a true biosignature. The University of California, Santa Cruz has established a framework for assessing alien worlds based on those conditions. One molecule is not going to give you the answer. You have to take into account the planet's full context. Lead author Maggie Thompson, a graduate student at UC Santa Cruz, said in a statement. To see if there is life on a planet, you must analyze its geochemistry, how it interacts with its star, and the numerous processes that might alter its atmosphere over geologic timeframes. While methane has been long considered a biomarker, it can also be created by non-biological activities, such as volcanic eruptions or asteroid impacts. As a result, when it came to identifying atmospheric methane as a biosignature, the researchers at UC Santa Cruz focused on lowering the chance of false positives. By concealing the light of planets' parent stars with an equipment called a chronograph, Webb may be able to directly image some of those dim, distant worlds in orbit, including those that are actively forming. It can also detect molecular signatures in the dayside light of planets. Planets will appear as silhouette as they pass between their stars and the telescope for a brief period of time, with starlight shining through from behind them. Webb will read the signatures of the gases the light traveled through in that starlight. Despite the fact that the Webb team has already supplied a number of photographs, these were all early alignment images taken to evaluate the observatory's capabilities. According to NASA, the images will be released on July 12th, when each piece of equipment has been calibrated, tested, and given the green light by its research and technical teams. According to NASA, it's difficult to predict how the new images will look after months of painstaking alignment after Webb's launch. Webb's high-resolution infrared vision of the universe will be unique since it works in deep space and has an 18-segment hexagonal mirror that takes exact images believed to portray the first galaxies early in the universe's history. When Webb captures its first photos, it will continue its scientific observations, examining the mission's key science themes. Through a competitive process, teams have already applied for time to use the telescope during its first cycle, or year of observations, as astronomers describe it. To make the most of the telescope's time, observations are methodically organized. The initial goal for JWST is to investigate the TRAPPIST-1 planetary system, which is 40 light-years away from Earth. This system consists of 7 rocky planets the size of Earth orbiting a cold red dwarf star. 3 of the rocky planets are in the habitable zone, meaning liquid water might exist on their surfaces. The TRAPPIST-1 star is about 1/10 of the mass of our Sun and is much cooler, but the planets orbit close enough to receive light levels comparable to those experienced on Earth. It's possible that the universe is teeming with life, or that we're completely alone, stranded on a lonely planet in the vastness of space. In either case, the precise solution will almost certainly necessitate significant psychological and philosophical adaptations on the part of humanity. Do you think Webb could discover alien life given its capabilities? Comment below.